This video is on an introduction to kinematics. Now, when we talk about kinematics, we're typically talking about motion. And in this case, we're talking about motion in just one dimension. In one dimension, I mean in either the x direction or the y direction. Add vectors together because they're all acting in the same direction. So when we do this, we're going to use a few different things. So we're going to do position, for example, in meters. We're just looking again at units. We're going to do velocity. Is going to be in meters per second, and acceleration is in meters per second squared. So if velocity is 10 meters per second, that's telling us how quickly our position is changing. So every second, our position changes by 10 meters. All right? Now, acceleration is a little different. But if the velocity was 10 meters a second, and let's say our acceleration is 0, meaning the velocity is not changing at all. So at time equals 0, our position might be 0. I mean, we can set this, but let's just say it's 0. So at time equals 1 second, our position is now equal to 10 meters. And at time equals 2 seconds, our position is now equal to 20 meters. So on and so forth. At 5 seconds, put some dots to indicate the passage of time. At 5 seconds, our position is 50 meters. Pretty straightforward. This is when the acceleration is equal to 0. Now, you could change this. You could have a negative velocity, for example. If the velocity was negative 10 meters per second, that means our position would be negative 10 meters a second, negative 20, negative 50, meaning that you start at a position of 0, you're moving in the negative direction, and you end up, after 1 second, 10 meters in that negative direction. Now, the acceleration is going to be how much the velocity changes. So let's say this time that our velocity starts at 0 meters per second, and that our acceleration is 10 meters per second squared. So at time equals 0, our velocity is 0. We're not moving at all for velocity is 0. Our acceleration is still 10, but we're not moving. But after 1 second, our velocity is now equal to 10 meters per second. We've sped up. After 2 seconds, our velocity is now equal to 20 meters per second. And so on and so forth. So each second, we're speeding up. 3 seconds, our velocity is 30 meters per second. So the question I'm going to ask now is, how far have we traveled after 3 seconds? If you look at this, think for a second before I explain the answer. How far have we traveled? You might be tempted to say, it's been 3 seconds, our velocity is 30 meters per second, 3 times 30 3 seconds times 30 is equal to 90 meters, right? But that's wrong. It's a common mistake, but it's wrong. Because the car didn't start at 30 meters per second. This would work if the car started at 30 and ended at 30. But it hasn't been traveling at 30 the whole time. It started at 0. Now v naught means its initial velocity. It ends at 30 meters per second. So in this case, you can actually find the average velocity. And if you want, multiply the average velocity by 3 seconds. So let's say the average velocity is just the initial plus the final divided by 2. You're just averaging two numbers. So v naught plus v divided by 2, or 0 plus 30 divided by 2. So our average velocity is 15 meters per second. So there's really only one instant in time when you were traveling at 15 meters per second. That was at 1.5 seconds. But that is, over the first 30 seconds, the average speed at which you're traveling. So now you can say distance is average velocity times time, or 15 meters per second times 3 seconds, which is 45 meters. I'm going to talk about some other problem-solving techniques in the next video as well. But it's important to remember that even though the average velocity is 15 meters per second for the first 3 seconds, it is not 15 meters per second if you pick any other time interval. If you pick 2-second time interval from 0 to 2, the average speed is going to be the average of 0 and 20, so the average is 10. So for the first 2 seconds, your average speed is 10. For the first 3 seconds, your average speed is 15. And then it keeps increasing, so on and so forth. You will see more about kinematics in the next video. This is the end of this video. Thank you very much.